That was my husband playing an introduction for the binomial theorem. Clap your hands for my husband. So now we're going to take a look at Pascal's triangle and how to actually use Pascal's triangle to expand a binomial. And this is the process that we're going to use is called the binomial theorem. Okay, so the very first thing that you're going to do is you're going to take a look at your exponent. What is your binomial being raised to? It's being raised to the power of 3. So we are going to locate the third row in our Pascal's triangle. And remember, our top row starts at 0. That's row 0. And we count 1 down for each row. So our third row has 1 more element in it than the row numbers. So row 3 would have 4 elements. We're going to take those numbers in Pascal's triangle and we're going to leave nice big spaces in between, and we're going to write them out. Then what we're going to do is we're going to take our first term, which is a positive x, and we're going to write it in parentheses next to each one of those coefficients. All right, once that is written, we are going to take our second term in our binomial, which is a positive 2, and we're going to do the same thing. We're going to put a positive 2 next to the x on all of our terms. Then we're going to start using our exponent up here. The first thing we're going to do is we are going to start with our x's, our very first term in our binomial, and we're going to start with the exponent of 3, and we're going to count down to 0. Then we're going to take, instead of starting with our exponent here, we're going to start with 0, and we're going to count up to 3 for our second term. So we start at 0, 1, 2, and 3. These are the terms of the polynomial that will be created if we cubed this binomial. So in between, since these are terms, we're going to put plus signs. We're going to add. So now all we have to do is simplify each one of these terms. And just as a reminder, anything raised to the 0 power is 1, so we can cross these off. They kind of don't exist. They equal 1. So let's simplify this. 1 times x raised to the third power is just x cubed. X squared. Now we have here, look, we have 2 numbers that we have to multiply. 2 to the first power is 2. 2 times 3 is 6. That's a positive 6. And our variable is going to be x squared. Here we're going to have 2 numbers again, but 2 squared is 4. 3 times 4 is a positive 12. And x to the first power is just x. And then our last term, 2 cubed, is 8. So the answer to this problem is this polynomial right here. So how is that going to be different than if you had x minus 2 cubed instead of x plus 2? Well, we're going to do the same exact thing, but for our second term here, instead of putting a positive 2 in here, we're going to put a negative 2 in because that's the sign in front of that number. So let's go ahead. We're going to look for row 3 in our Pascal triangle and write those numbers out. 1, 3, 3, and 1. We're going to take our first term, which is a positive x, and we're going to put it in parentheses next to those coefficients. And we're going to take our second term, which is now, instead of a positive 2, it's a negative 2. And we're going to put our negative 2 in parentheses next to our x's in each one of these terms. We're going to put our pluses in the middle, and then we're going to add our exponents. Again, remember, we start with our first term. We always start with our highest exponent, and we count down. 3, 2, 1, 0. And for our second term, we always start with the lowest. We start at 0, and we count up. 2 and 3. And the last thing we have to do is simplify. Remember, anything raised to the 0 power is just 1, so we'll just go ahead and cross those off. And we'll just simplify each of these terms. X cubed is just x cubed. What is negative 2 to the first power? Is just negative 2. So we have these two numbers to multiply, which gives us a negative 6. And then our x to the second power is just x squared. Now what happens when we say negative 2 times negative 2? Well, that is a positive 4. So we have to multiply positive 4 and positive 3 gives us a positive 12 times x to the first power. And then we have negative 2 cubed. Negative 2 times negative 2 times negative 2 is going to be a negative 8. Negative 8 times 1 is a negative 8. So if you cubed x minus 2, you would get this polynomial right here. And I want you to notice the difference in the terms. The terms are exactly the same. X cubed and x cubed, 6x squared, 12x and 12x, 8 and 8. The difference occurs with the signs or the operator that's being done between the terms. Whenever you have a negative, you're going to notice that your operators are going to go back and forth between a minus and a plus, or you might have a plus and a minus depending on the power you're raising it to. So that's the end of this lesson.